Welcome to our deep dive into Babylonian mathematics. You've sent over some notes dated December 16th, 2024, and the Wikipedia page on the topic.
Oh, wow.
Quite the combination.
Yeah.
I'm excited to uncover the most intriguing insights from these sources with you.
It's incredible to think how traces of Babylonian mathematics,
Right.
a system developed thousands of years ago, are still present in our modern world. Take, for instance, our measurement of time, the division of an hour into 60 minutes,
Right.
and a minute into 60 seconds. This sexagesimal system has its roots in ancient Mesopotamia.
That's a great point. It's easy to overlook how deeply embedded ancient knowledge is in our daily lives.
Yeah.
To truly grasp the significance of their Base-60 system.
Right.
Let's set the stage.
Okay.
Could you paint a picture of ancient Mesopotamia and the Babylonian civilization for us?
Imagine the Fertile Crescent of Mesopotamia nestled between the Tigris and Euphrates rivers
Okay.
around the 5th to 3rd millennia BC.
Wow.
This is where the Babylonian civilization flourished, making significant contributions to astronomy, law, architecture, and of course mathematics. Their writing system, cuneiform, played a crucial role in preserving this knowledge. Using wedge-shaped marks impressed on wet clay tablets, which were then baked.
Wow.
They were able to record and transmit their mathematical discoveries.
These clay tablets truly are windows into the past.
Yes.
Now, let's delve into their unique number system.
Okay.
They didn't use base 10 like we do, right?
Correct.
Okay.
The Babylonians used a Base-60 system,
Okay.
also known as a sexagesimal system. Now, you might be thinking, why 60?
Yeah, it
seems like an oddly large number to base a counting system on.
Right.
However, there's a brilliant logic behind their choice.
Okay.
The number 60 has an impressive number of divisors. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60.
Wow.
This unique property made dealing with fractions significantly easier compared to a base 10 system.
So having all those divisors simplified calculations with fractions. I can already see how this would have been beneficial for a civilization developing sophisticated astronomical knowledge.
Absolutely.
But how did they perform these calculations? Did they have some ancient form of calculator?
Not exactly a calculator,
Okay.
but they had a remarkably ingenious tool.
Okay.
Pre-calculated tables.
Interesting.
Imagine clay tablets filled with squares, cubes, and reciprocals,
Right.
ready to be referenced for complex calculations.
Wow.
These tables were essential for simplifying multiplication, division, and even solving equations.
These tables almost sound like ancient spreadsheets. Can you give us a specific example of how they used them?
Absolutely.
All right.
Let's say they needed to multiply two numbers, a and b.
Okay.
They used a fascinating formula.
Okay.
AB equals open parenthesis, a plus b, close parenthesis squared, minus a squared minus b squared, all divided by 2.
Wow.
So instead of directly multiplying, they
Yeah.
could simply look up the squares of a plus b, a and b in their tables. Plug the values into this formula and arrive at the product.
That's a clever workaround. It seems they had a deep understanding of mathematical relationships to devise such methods.
Yeah.
But their mathematical prowess went beyond arithmetic, didn't it?
You're absolutely right.
Yeah.
Evidence suggests that the Babylonians were adept at algebra,
Oh, wow.
even grappling with concepts like the quadratic formula,
Really?
albeit in a slightly different form than we use today.
Yeah.
Their focus was on equations of the form x squared plus bx equals c, where c was always positive.
Wait, they were solving quadratic equations thousands of years ago.
Yes.
I'm genuinely curious about how they approached this without the modern algebraic notation we rely on.
They developed methods for approximating square roots using division and averaging.
Right.
This was crucial for solving those quadratic equations.
Right.
And highlights the remarkable ingenuity given the tools at their disposal. Their mathematical thinking extended to geometry as well, as they demonstrated an understanding of the Pythagorean theorem and its practical applications.
It's incredible how much they were able to achieve without the tools and notation we take for granted today.
Yeah.
It really underscores their contribution to the foundations of mathematics.
Precisely.
Yeah.
And we're just scratching the surface.
Wow.
Their insights into pi and their work with Pythagorean triples are further testaments to their mathematical sophistication.
Okay.
But perhaps we should delve into those fascinating areas in the next part of our deep dive.
Yeah, let's definitely.
Okay. Welcome back to our exploration of Babylonian mathematics. I'm eager to dive into those fascinating areas we touched upon earlier.
Right.
Their insights into pi and their work with Pythagorean triples.
Yes. Let's start with pi. Did they actually calculate its value in the way we understand it today?
While they didn't have the concept of pi as an irrational number, they did have a surprisingly accurate approximation.
Oh.
A clay tablet unearthed near Susa, estimated to be from the 19th to 17th centuries BC, revealed they used the value 258, which equals 3.125.
That's remarkably close to the actual value of pi. What's truly intriguing is how they managed to achieve this level of accuracy without the advanced tools we have today. What are some of the theories about their methods?
The exact method remains a subject of debate among scholars. However, some suggest it might have been derived through meticulous geometrical observations and calculations involving circles and polygons.
Interesting.
It speaks volumes about their keen observational skills and deep understanding of geometric principles.
It's fascinating to think about the ingenuity required to make such advancements with limited tools. Now let's move on to those Pythagorean triples you mentioned. Could you remind us what those are?
Of course, Pythagorean triples are sets of three integers. Let's call them a, b, and c,
Okay.
where a plus b equals c.
Mm.
In essence, these triples represent the sides of a right triangle that satisfy the Pythagorean theorem.
Ah, Pythagorean triples, right. Those always fascinated me. So how do the Babylonians fit into this picture?
One of the most remarkable Babylonian clay tablets, known as Plimpton 322, contains a list of these Pythagorean triples.
Wow.
What's particularly intriguing is that some of these triples are quite large, hinting at a systematic method for generating them, rather than simply stumbling upon them.
So they weren't just randomly finding these triples, they seem to have a deeper understanding of the relationship between these numbers.
Exactly. The sheer number and size of the triples on Plimpton 322 suggest a level of mathematical sophistication that continues to intrigue mathematicians and historians today. There's ongoing debate about whether they had a formal proof for the Pythagorean theorem, but their knowledge and application of these triples is undeniable.
It makes you wonder what other mathematical secrets might be lying dormant within these ancient clay tablets waiting to be deciphered. Their mathematical prowess wasn't confined to theoretical concepts, though, was it? They applied their knowledge to other fields like astronomy.
Absolutely. Their mathematical skills were intricately woven into their astronomical observations. The Babylonians were meticulous record keepers of celestial events, tracking the movements of stars and planets with impressive accuracy. These records required a profound understanding of angles, timekeeping, and even a coordinate system based on the ecliptic. The path the sun appears to take across the sky throughout the year.
It seems their mathematical knowledge was fundamental to their understanding of the universe.
It was.
It's incredible how they integrated these complex concepts into their observations.
And here's where it gets even more fascinating. In the 1950s, scholar Otto Neugebauer made a groundbreaking discovery. His research suggested that the Babylonians used a rudimentary form of Fourier analysis in their astronomical calculations.
Fourier analysis, isn't that a relatively modern mathematical concept?
That it is.
To put it simply for our listeners, imagine taking a complex wave, like a sound recording, and breaking it down into simpler waves, like you'd see on a piano tuner. That's essentially what Fourier analysis does.
Precisely. It's a powerful tool used today in fields like signal processing and data analysis. The fact that the Babylonians, with their clay tablets and Base-60 system, had a grasp of this concept even in a basic form speaks volumes about their advanced mathematical thinking. They were centuries ahead of their time in many ways.
Their insights are truly remarkable. Now, we've been discussing the Babylonians' achievements, but it's important to acknowledge the role of modern scholars in bringing this knowledge to light.
Absolutely.
Can you tell us more about the contributions of researchers like Otto Neugebauer?
Absolutely. Otto Neugebauer's work was instrumental in deciphering and interpreting Babylonian mathematical texts. His book, The Exact Sciences in Antiquity, is a cornerstone in the field, providing a comprehensive overview of Babylonian mathematics and other ancient scientific achievements. Other scholars like Eleanor Robson have further enriched our understanding. Her book, Mathematics in Ancient Iraq, A Social History, delves into the social and cultural context of Babylonian mathematics, demonstrating how it was deeply embedded in their daily lives.
Their research is invaluable in bridging the gap between these ancient civilizations and our modern understanding. It's thanks to their meticulous efforts that we can appreciate the brilliance of Babylonian mathematicians.
Indeed. And while we've uncovered a great deal,
Yeah.
there are still many mysteries waiting to be solved. The
Right.
Babylonians' approximation of pi, for instance.
Okay.
We know they used the value 258, but the precise method they used to reach this approximation remains an enigma.
Mm-hmm.
The same goes for Plimpton 322.
Right.
Did they have a formal proof for the Pythagorean theorem?
Yeah.
Or did their understanding rely on empirical observations and geometric intuition?
It's like a giant puzzle with pieces waiting to be discovered and fitted together. Each clay tablet holds the potential to unlock new insights and deepen our comprehension of this ancient mathematical system. I'm eager to hear about the resources available for those who want to delve deeper into this fascinating subject.
Let's explore those resources in the final part of our deep dive. There's a wealth of information waiting to be discovered both in physical archives and in the vast digital landscape.
Welcome back to the final part of our deep dive into Babylonian mathematics. This journey through ancient mathematical thinking has been truly eye-opening. I'm particularly struck by how they managed to make such significant advancements with the tools available to them.
It's a testament to their ingenuity and deep understanding of mathematical concepts, and as we mentioned earlier, there's still so much to learn from their legacy. So for those listening who are eager to continue this exploration, let's delve into the resources available for further study.
Yes, let's start with something tangible. What about museums? Are there any institutions where people can actually see these ancient clay tablets in person?
Absolutely. Many museums around the world have collections of Babylonian artifacts, including mathematical tablets. The British Museum in London, for instance, houses a remarkable collection, including the famous Plimpton 322. Seeing these tablets up close with their intricate cuneiform markings could be a truly awe-inspiring experience. It connects you to the scribes who meticulously recorded these mathematical insights thousands of years ago.
It's like having a direct link to the past. I can imagine the sense of wonder you'd feel standing before those tablets. Now, for those who prefer a deep dive through reading, what are some essential books on Babylonian mathematics?
As I mentioned earlier, Otto Neubauer's The Exact Sciences in Antiquity is a classic. It provides a comprehensive overview of Babylonian mathematics and their scientific achievements. For a deeper look into the social and cultural context, I recommend Eleanor Robson's Mathematics in Ancient Iraq, a social history. It sheds light on how mathematics was interwoven into their daily lives.
Those sound like excellent starting points for anyone wanting to embark on a scholarly journey. And in today's digital age, I imagine there must be a wealth of online resources as well.
You're absolutely right. Websites like the McTutor History of Mathematics Archive offer a treasure trove of information on Babylonian mathematics. You can find translations of clay tablets, detailed explanations of their mathematical concepts, and even interactive tools to try out their methods firsthand. The Mathematical Association of America's website is another great resource with articles and materials dedicated to this fascinating subject.
It's incredible how accessible this ancient knowledge has become, thanks to the dedication of researchers and the power of the internet. It's almost like having a virtual time machine at our fingertips.
Exactly. And who knows, maybe one of our listeners will be inspired to make their own contributions to the field. Perhaps someone will unlock the secrets behind the Babylonians' pi approximation or uncover new insights from Plimpton 322. The potential for new discoveries is truly exciting.
It's a reminder that the pursuit of mathematical understanding is a continuous journey spanning across millennia. This deep dive into Babylonian mathematics has not only been fascinating, but it has also underscored the enduring impact of their ingenuity and their contribution to the foundations of mathematics.
Well said. The story of mathematics is a story of human curiosity, innovation, and our constant desire to make sense of the world around us. And as we've seen with the Babylonians, it's a story that continues to unfold, revealing new insights and inspiring future generations of mathematicians.
So to everyone listening, keep exploring, keep questioning, and who knows what mathematical treasures you might uncover. This has been a captivating deep dive, and we thank you for joining us on this journey.